very happy to have you here. And if you want to learn more, you've already been intrigued already by the presentation which Mr. Olumayowa has done for us. Then please reach out to Doyenify or Mr. Olumide, and they can guide you on the next steps. So, now we are going to have another speaker, and this speaker is coming all the way from America to share his knowledge with us. I believe America is a place where we have a lot of tech people there as well. So you're going to be getting some knowledge from the next speaker. His name is Mr. Tolulope Odetola, and he's into artificial intelligence, he's into machine learning, and I believe he's ready to share his skills, his knowledge with us, so that you would know what you are getting into when it comes to machine learning or artificial intelligence. So, Mr. Tolulope, can we have
I think you are making a mistake. It's Dr. Tolulope Odetola.
Wow, my bad. I'm very sorry about that. It's not easy to be a doctor. Dr. Tolulope Odetola, sir. Can we have you?
Thank you very much, Tolu. It's good to be here. When can I share my screen?
Yes, please go ahead, sir.
Yes. Sure. Can you see the slides?
Yes, I can see the slides now.
Thank you. Thank you very much, everyone. It's good to be here. When Benga called upon myself to at least join Doyenify, it was a yes immediately. So a bit about myself. For my bachelor's, I did electrical and electronics engineering from Obafemi Awolowo University. I have a master's and doctorate from Tennessee Technological University. And my first job was actually as a business analyst, where I met Benga and also Olumide Oyalola. I worked at Venture Garden Group and as a business analyst. Then I worked as a project manager in Garden Data Analyst, where we did some actionable insights for the Vice President dashboard, right? And then I went to pursue graduate studies for my master's and my doctorate. And I worked in Boston Scientific, and I currently work at Whirlpool for smart appliance and home automation. So that's a bit about myself. So feel free, as we go through the slides, to ask questions. Feel free to pop messages on the chat and let me know. So artificial intelligence and machine learning. What is it about? So AI has been a buzzword from time immemorial, I think from the 1890s. One of my professors in college when I was doing graduate studies was one of the first set of people to work on AI with, I think, NASA. And when he was telling us, it was like he never knew it would blow to this stage, right? So what is AI in itself? AI is the science of creating machines that can think like humans, right? But the whole goal is trying to mimic what the brain looks like, right? Now, a subset of artificial intelligence is machine learning, right? Machine learning uses algorithms to train data sets, create models to perform tasks with limited human intervention. So, what is this? What is that? So deep learning is a subset of machine learning, and then generative AI, like your Transformers, your ChatGPT, Gemini, I think Elon Musk has his own Claude AI. All those things we use are all generative AI. Generative AI are very, very much creative. Like their name says, they generate intelligence. Now, if you look at the scope, so we will see that AI in itself leads to machine learning. The subset is deep learning and generative AI based on, should I say, focus. There was a time deep learning was the main thing, computer vision, right? Convolutional neural network was the main thing, but now it's the GPTs, right? So if we go to the next slide, what does machine learning market look like? In the next 10 years, at least from now, averagely, right, it's going to be like a $714 billion company, right? Is a business, it's going to be a $714 billion, market, right? And it's growing. It is growing and is bound to grow exponentially, right? And so that means that there is still room, way much more room for people to, grow skills and come into this market, right? Like if you're asking the question, is it too late? What is in it for me? Is it too late to start? No, it is even too early to start, right? So that is it. Now, this was gotten from levels.fyi. This is the average salary, and this is recent, right? This is about a year ago of people in machine learning, right? Median salary. This is based on location though, right? But this is the median salaries of people that have AI or AI focused, job roles. So it can be a machine learning engineer, a computer vision engineer, etc. Different specializations within machine learning. Now, this is also a kind of like comparison between the amount of money people make in AI in different companies and what people make in those companies that are non-AI related roles. So if you look at the red is AI, and if you notice, it's only in some places that there is they are comparable, right? But in many top companies right now, attention is given to people that work in the AI space, in the AI domain, right? So this just shows that the world right now is paying attention to AI. AI is the buzzword, right? Buzzword. If you go on Google and touch most used buzzword now, AI will be part of the top 10 words, right? So what is AI? AI, like I said, from 1991, 1948, I think, right, has been in existence, right? Different technologies and different companies have come up with different AIs over time. From this is just showing the 2000s, and is also showing that based on the evolution of machine learning, based on the fact that there's an information age with social media, people just push out information. That means there's access, and we just sign all these when we are signing up, we sign all these terms and conditions, and we subconsciously give people permission to use our data. They train different intelligence, and these different intelligence are what we are seeing in existence today. And this is also showing you that because of much information, right, we can train technologies and intelligence that uses a lot of parameters. Now, we'll go into these details later to understand it, but this is just to show that many companies, top companies that we know, are paying attention to machine learning. Now, just like I said, machine learning has been in existence from time immemorial, from 1943, and I'm sure it started way from then when, people wanted to stop doing tasks that were monotonous. It went on to machine learning, to CNNs and everything. But this is what we can see now, because this is what is useful to us now. ChatGPT, AutoGPT, and the likes, right? Now, if we zone into machine learning, what is machine learning? Machine learning is divided into, three major parts: supervised, somehow four, right? There's supervised, there's unsupervised, there's semi-supervised, and there's reinforcement learning, right? So what is supervised learning? Like I said, we are trying to train intelligence that looks like human beings. So if I will zone in and replace machine learning with human learning, right? If you go to your secondary school, in your secondary school, we were trained with something called supervised learning. Let me go to the next slide. We were trained with something called supervised learning. So what that means is this, right? When you were in GSS1, right? Or let me say SS1, they wanted to teach you simultaneous equation. So your math teacher comes in and say simultaneous equation. That's my problem statement. I want to be able to solve two or quadratic equation. I want to be able to solve two variable equation with this. What did he first do? It will give you the question. It will give you many examples. Many examples. Those examples are what we call labeled data. So those examples is that, oh, you know what? This is by factorize. So for simultaneous equation, the substitution method. Which other method is there? I've forgotten, but we know all those methods, right? The substitution, there's elimination method. This is elimination method. This is this. This is X, this is Y. It can be A, it can be B. This is how you solve theory. You can use matrix method. You can use determinant method. You can use different methods, right? So now all those methods that you use, substitution, are what we call different algorithms, right? But this is X, this is Y. So in this scenario, this is labeled data. The labeled data is that use supervised learning to know the type of shapes, come up with an algorithm to recognize shapes. So I'll give it all the shapes. But in the process of training, I will label it that this is hexagon, this is square, this is triangle, right? I will label it. That labeling is when I'm telling that this is an example of hexagon. This is an example of how you solve X, example of how you solve Y. When it trains finish, now when you are done with all your examples, classwork, homework, corrections, what do your teacher do? Your teacher will give you a test, like classwork, or they'll give you assignments. Yes, they'll give you tests, test 1, test 2 exam, right? And based on your performance, if your performance is 8/10, 9/10, they will send you either for a competition, or they'll say they are preparing you for WAEC or for JAMB or the likes, and then you get a good result and you go and show your parents. So that's what it is. This is when it's deployed to the field. And that's when the technology, the previous speaker, this is when we hand it to them and they're like, oh, DevOps, it's time to, run some tests in their environment, right? So it's all kind of like that collaborative environment. So that's what supervised learning is about. Unsupervised learning is when you are a graduate, you don't know anything. You are just sent out to the job market. You don't know what to say during an interview. You don't know. It's just like sending you out to the job market. It's just like being an adult. Nobody is telling you what is right. Nobody is telling you what is wrong. You're an adult. You know what you have to do. So it is you on labeled data. You don't know what this algorithm does not know if it is a square, it is a rectangle, it's a triangle. It's just knowing that when I tried this looks like this. Good. So maybe as an adult, you tried a set of actions that led to bad. Nobody's telling you don't smoke. Nobody's telling you don't go to the club. Or some people are telling you go to the club. You don't know if it is right or wrong. But you did a process of actions or a set of actions that led to something good, or a process of actions that led to something you enjoyed, or some process of actions that led to something bad, bad based on what you define as bad or what you define as good, right? So all those things, so you are learning on your own, on the go, right? So that is what unsupervised learning is. Nobody is there to coach you. Now, reinforcement learning is how you train a dog, right? So say, for example, if you watch many of these dog trainers, please let me know. Hope I'm carrying everybody along. Can everybody still hear me?
I can hear you, yeah. I can hear you.
So reinforcement learning is how you train a dog. So maybe you have a dog now and you want the dog to be able to say, hey, sit, stand, jump, attack, this, that. So if you watch all these dog training videos, what they will do is they will take a lot of food, right? A lot of food. And they will say, come. When they say come, right? If the dog comes, they give it food, right? They positively reinforce it that, oh, if I do this thing, I'm getting a prize. Now, if you say, come, no, stop it, they'll be like, oh, there is a harsh, aggressive, reaction from my owner, from the person that I seek validation from, I am going to not do that again. And over time, they train. So reinforcement learning is actually how we train babies, infants, and all those people that can't decipher, or all the entities that can't decipher right or wrong, if that makes sense. So it's just a very good, applicable, relatable way by which we see this learning, right? So now, these are the kind of things we do. We have supervised, unsupervised reinforcement learning. under unsupervised, you have to give it a data, right or wrong, triangle or square. So in classification, so we have classification. In under supervised, we have classification. Classification is that, okay, all these are triangles, all these are rectangles, right? Regression can be, classification is for discrete data. What are discrete data? Discrete data are data that are categorical. So what I'm saying, Mr. Oyalola was talking, it was like male or female. We know it is either male or female. It is categorical. It's either one or two, right? So we can classify them into two sets of groups. You understand? We can classify into different cats. For example, this is lion, this is leopard, this is panther, this is different things, into shapes, right? Whatever is categorizable is classification. There are different classes of their own. Regression is if you want to predict what is the height of, Tolulope. What is my height? My height can be 16.158, blah, 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 blah. So for continuous data, we use regression. Clustering is when you are under supervised, when you're trying to generalize. This set of actions are good. You cluster things into this. I'm sure just like your peers, there are some guys that you call when it's time to jaye, you have categorized them, or when it's time to go and enjoy yourself. And there are some guys you call when it's time to study. There are some guys you call when it's time to read the Bible or talk religious talk. There are some guys you call when it's time to talk football, or soccer, or makeup, or whatever. And reinforcement learning. There are some guys you call when you are brainstorming, when you just want to brainstorm, right? It's just like you're starting a business. What should we do right? We don't know what we'll do right or wrong, but let's try this. We experiment and know. So back to one thing the first speaker said was that, data is gold, and data will be gold for the next decade, right? Data is gold. And what happens is this is the whole process flow. And that's why when Mr. Oyalola was talking, it was like, when we have the data, cleaning the data is 80% of the work. If we have clean data, just imagine a teacher comes in and gives you bad examples. With those bad examples, he can't expect you to pass WAEC. No. He has to give you very good examples so you can do your test, do your classwork, do your assignments, do your exam, then do your WAEC, right? So in this AI method, there's data. Now, what are those data? We have to have a subject matter expert, which is your teacher. Those just subject matter will tell you some rules that are abiding. So when it tells you those rules, right, that, substitution method, use factorization method, use quadratic formula method, this is the formula for area of a triangle, this is the formula for area of a parallelogram. If you are doing, what are those difficult concepts in maths? Elevation and depression, this is how you do. So Catois, all those things, it tells you those rules.
All of Lagrangian.
Lagrange, yes. All those, it tells you those rules. Then it now tells you the best method to apply those rules. That's the algorithm. So this lies here, the algorithm. So you have a problem. They've given you a data. They've given you the data, they've given you the scenario. You already have the rules. What is the best method to apply these rules? So should I use a neural network? Should I use reinforcement learning? Should I use unsupervised learning? Should I use supervised learning? Is it computer vision, right? So if I come and I say, write me an algorithm write me an AI model that counts all the Audi cars on the highway, right? So that means that you have to look, when you look, you have to recognize, you have to count. That is computer vision, right? Or write me an algorithm that will translate. That is natural language processing. So from the problem, you get the definition, you know the rules, you know the constraints, and then you can do all these capabilities. Like when you're watching YouTube now, even as you're talking, it is making the transcript for you. Many of this is when you look at your phone has the T recognition of your face, which is that's why whenever it sees a face, it knows the eye to mouth location and say that is a face, and those boxes or face detection follows it. So we can do a lot of identification like that. If you see, systems are becoming much more intelligent, right? So stuff like that. So these are the applications, and these are some other applications. You can go to manufacturing, you can go to retail, you can go to healthcare, right? You can go to travel and hospitality, you can go to financial services, you can go to agriculture. I'm going to share some examples. So say, for example, in manufacturing, it can be defect detection. Maybe you make cylinders, maybe you are working with a welder or a crazy and you're welding metals together, but sometimes some alignment doesn't go through. You can attach a camera, watch it and say, oh, you know what, this is not perfect, send out. This is not perfect, send out. So in real time, you can make data-driven decision in real time that will be cheaper, that will have so much quality, so much safety to it. For example, right, look at in energy power sector. Let's say I have a laundromat and people come and wash their clothes where I am. And this can also be, for example, let's say you have a game center or a barbing salon, right? If I use analytics, you give me the data of your customers, you give me the data from NEPA, you give me the data of PHCN, you give me data from all these things. I can tell you that the best time to open your shop is between 8 a.m. to 9 p.m. Why? Because the tariff at this time is lower. So your meter will be reading smaller amount of charges, while if you can get your customers to come at this time, you will pay small NEPA bill and you will get the same amount of. So we can do a lot of profit optimization. We can catch fraud, a lot of fraud alerts. We can do all these things. All these capabilities are because AI exists, data exists. And some of the applications are smart retail. For example, if you enter ShopRite, right? If you go to ShopRite, the way they arrange those commodities is data driven. You understand? So they put a lot of sweet stuff, baby stuff at the end, because they know if you walk through to the end, you'll have seen something else that you think you want or you like that you want to have. A lot of things, autonomous driving, self-driving cars are there now. They exist. They know where the cameras are. They do a lot of image segmentation, stuff like that. Agriculture, I will shed a lot into agriculture. So one of the research I had to do in some of my internship was use TinyML. So my specialization in machine learning is TinyML, tiny machine learning, where we have to, some of the applications of TinyML is that, how can we protect animals from poachers, right? How can we protect animals from poaching? So they kill elephants, they kill lions. So with TinyML, you can embed it on the animal, and in real time, it can tell, okay, you know what, this animal, there's poachers, this animal are migrating because of food, these animals are fighting because maybe it is mating season, stuff like that. We can monitor animals, we can count animals, we can detect if wild animals are around, different stuff like that, right? So many applications. So these are the current trendy things a lot of us have. I don't know what this is called. The wristwatch you wear to monitor your activities. So wearable devices. We have a lot of virtual assistants. You'll be typing on your computer and it's guessing the set of words. That's natural language processing. Security, IoT, augmented reality, Apple Vision Pro. All those things that have embedment of artificial intelligence in them that helps them to be much more relatable to do, right? And these are some of the tools that we'll work with. We'll take some of the skills in data science, some of the skills in database management, some of the skills with generative AI, and that will make us a full, all well-rounded person in, machine learning and AI, right? These are some of the prerequisites or things we need to know or learn in AI. So, I think, that's all. So in Doyenify, right, the plan or goal is to make us, to not bug us a lot with the theory, because actually, in the sense, there are people in school that would, be worried about that, right? Applied learning. So what that means is that, in Doyenify, we tackle it project by project, repeatable learning. So where, for example, let's attack fraud detection in the banking industry. What type of data do we need? Boom. How do we know what fraud is? Should we use supervised or unsupervised learning? What kind of things is going to happen? Stuff like that. How do we detect, for example, and these are just ideas I'm throwing out there. Yahoo boys, right? Yahoo boys is plaguing Nigeria, spoiling Nigerian name. How can we detect people that are Yahoo people? You can generate real life solutions to make life better. So I have a little demo. So it's kind of like a little chat GPT I have, but not just chat GPT, but like a situation where you can customize your chat GPT using large language models. So if you come to the slide, some of the tools or prerequisites we'll go through is LangChain, OpenAI, Hugging Face, stuff like that enables us to build something like this where you can create a chatbot or a chat GPT and you can tell it its personality, right? You can tell it its personality and say, you know what, I'm going to stop this and I'm going to run it again. You know what, you are a psychologist, right? And I want you to, help me with this. And I can say, hello. Of course, it's not refined because it's in the works. I can say hello. It's going to, reply me, hello, I am a psychologist. I am here to help with any psychological concerns. Help me provide any information. I can say, what are psychological things? I am depressed. I am depressed, and I've instructed it that you should show empathy, show concern, behave like you're a human being. Now, this takes a lot of processing power, so I'm using Google Colab, right? It takes a lot of processing power. So it says, oh, I can help. Depression is a health disorder anyone of any age can have, right? The symptoms of depression can vary from person to person. Now, some of the symptoms, why is it showing all these symptoms? Because I said discuss the symptoms with me, right? It's showing the song. If you're experiencing of the symptom, it is important that you seek a professional help. I want some of the things to maintain a healthy lifestyle. So I can say I do and you can write down a lot of binge eating. I do a lot of binge eating, and what can I say? I do a lot of binge eating. Let's see what it says. So something like these are things you can build. Now, this is an example application. You can say, you're an expert analyst and you are an expert gambler, right? And I want you to show me all the betting things that I want to do about the Nigerian match that is coming. Anything. I need to go and check online and this. So, BGT is a coping example for emotional distress. So it is blah blah blah. So it will give you much more context, right? So of course, this is just an example application playing with. So you can write your own custom GPT. You can write your own custom things that send out as APIs and build your own fully fledged application, right? So this is just a little demo I prepared, and you can keep asking questions and all. So anyhow, I think so far that's all I have for today. So just the last part of the talk is if you come join the class with Doyenify, the question is not what you will learn. The question is how much you the question will be about how much are you willing to invest in yourself. You will guaranteed you are going to learn. Do you understand? You're going to gain a lot of skills, right? And is solely based on how motivated you are. There is market for the skills you have, right? And for the skills you will gain. And it's just going to be about how well your creativity will be what will limit you. The sky is your limit, right? So thank you very much, everyone.
Thank you very much, Mr. Tolulokwe. That was actually very exciting. I think in the field of AI itself is even very
Doctor.
ah, I'm so sorry. I'll pay fine today. Dr. Tolulokpe.
No worry. I'm still getting used to it.
Yes, so thank you very much for sharing with us here. I'm sure that you have some students already, like here on the call, or students to be people that are actually interested in AI. So please, if you are one of these people that are interested in AI machine learning, you want to create your own chat GPT, please reach out to Doyenify, reach out and join the cohorts. I think the cohorts generally will be starting like next week. So please reach out to Doyenify and secure your space now that Dr. Tolulokpe is still available. Someone is asking if you can share the PowerPoint with the participants. I don't know about that. Okay, he says yes, it's possible. So maybe in an email based on the webinar notification that you got. So maybe we'll share it with you through that. Thank you very much again, Mr. Tolulokpe. So my own question is, are you already building the next chat GPT already, or any
Um,
exciting projects?
so the thing currently, yes, for some of my friends and for some projects, I'm helping them build some custom-based GPT, because many problems or many concerns people have with ChatGPT or BARD is that when they type their data, they can't type something proprietary or secretive, because they assume that Google or Microsoft have access to it and then it's all in the world. So that's why a lot of people want to preserve their data and have their own custom-based GPT. So I've helped some people, build that. Though to make it into an application, we need like a UI UX person, generate APIs and all those dots together to make it a fully fleshed app. So one other concern I'm researching into is tiny GPTs, which is that ChatGPT now, the lowest one is 7 billion parameters. One parameter is, so your phone, we all talk in megabytes or gigabytes, right? One number is 32 bits. 4 bits make 1 byte. So one number is 1 byte. Multiply that by 7 billion.
Wow.
So one number is 4 bytes. So 7 billion times 4 bytes, that's 28 billion bytes divided by 4, that's 7 gigabytes. It can't stay on your phone, it can't stay on your cooker, stuff like that. So there are current research going into how can we simplify GPTs into smaller stuff without compromising accuracy. So those are research going in there. Sorry, sometimes I get carried away.
Please get carried away. It's very exciting. But thank you very much again, Mr. Tolulokwe. Very good to have you here. I hope I want to also thank all the participants that have stayed so far as well. We